Good morning. This is Cody Hendrickson. Today we're going to be looking at how we can do some simple array list searches that can help us understand how we can use an array list to process information and how we can use it to, especially using Java, so we can go through and find where something is or what kind of things are inside our array list via the actual operations that we have available for us. The first thing we want to do is take a look at the different kinds of types we can have that process those array lists. So the first type we have is an accumulator. Okay, we're going to count up the number of things and sum them up. We're going to eat all up the values. And those are either a summation or a count that matches. We also have another type we're going to do find the est around. We want to rank some information. And this is we're going to look in a little bit more detail at what's inside that. We also have the existence top. Now, we're not looking for an existential crisis. We can have those another time. Right now, we're saying, do you exist inside this list or not? So we actually want to find it. And finally, and possibly sometimes most important, where are you in the list? Where can I find you? The first thing we want to look at is the accumulator style. Okay, we want to count things up. So we want to accumulate some values. The first thing we have to do when we're doing accumulator style is we have to actually make sure we have a variable that's declared before the loop itself that processes that list, so we can store all the values that match or exist inside that. So we can eat all that contained value. So we have to have the external variable, aka the accumulator. We have to use the magic power of the plus equals operator, because we want to return and add into that value so we keep on building it up. So it's not just going to sit there and just stay. We want to make sure we accumulate values in that. Two major types. The first is the summation. We want to get all of the stuffs. Okay? So we want to find the contents of how much is stored inside the objects we're looking at. And so that'd be the total summation of that. Now that's great for getting a total value. And say, for example, we want to get all something that's stored inside something, like, oh, the total number of cells for all the different objects are inside that. Great accumulation. Then we want to find out what are the cells that match a certain category. And this is where we can approach some more of the data analysis components. This is more of the advanced searching. You'll see some of this sometimes on a free response question on the AP Computer Science exam. We also have the count the matching, because we want to go through and look through all the different items that are inside that list, and we want to not count all of it because that's just in .size. What we want to do is we want to go through and actually find, oh, here's the special cases. And we can use that with the count the matching. And again, we'll take a look at how to do that. The first thing we have is a summation style, and so we have a couple different code samples right here. We have the sum grossness on the left and some certain grossness on the right. And with sum grossness, we take a look at this. The first thing you see is that we have an int sum is equal to 0. Then we have for each zombie head, current head inside my zombie list, we're going to go through and add to the sum the current grossness level of each zombie head in that list. And we'll return that value back out to us. So we have our accumulator sum starts off at 0 because that's our default value. And then we add to that each value we have inside it. The more advanced version over on the right, with some certain grossness, we're using that same int sum equals z. We start with for sum zombie head current head inside my zombie list, again using the enhanced for because we want to do that to all of them inside the list. And then we want to go through and we want to ask a specific question. That's where we introduce the if block, because if is how we question things inside computer science when we're doing programming. And so the if block, we use the if current head.get grossness level. If that value is greater than 65, aka we've got a really gross zombie head that we're working with, then it's time to go ahead and say sum plus equals the current head's grossness level. And we return that value. When we're counting things, we want to go through and have an accumulator, but this time the count again starts off at 0. And just to count all of them have a value less than 50, I'm going to go ahead and add the if block on there using less than 50. And if it's small enough, it's just a tiny bit gross, then we'll go ahead and add that to our count. We can also count certain values inside strings. In this case, we have for zombie head current head inside my zombie list. And if current head.getName, which returns a string using method chaining right there, .compare to Jack, is greater than 0. So if we have something that comes after Jack, inside that alphabetically using capital letters, of course, then count plus plus and we'll return that count. And so we can count those certain names. Now, we also want to find sometimes the extremes. This is where we're actually looking at the data inside it. So we want to find the things that are really big or really, really tiny. In order to find the extremes in that, we want to actually make sure we can accumulate the values, but instead of using a build up the value, we want to replace the current value with the best current one that we're working with. And so in that case, we're going to start off with a value that's going to be represent something that we can actually, oh, here's what the biggest thing is, or here's what the smallest thing is. We can have that value that represents what the smallest. Now, most of the time when we're doing this, we're looking at numeric values, but we can also rank values themselves on a more grand scale. Like I want to compare this object to this object. That's a little bit more complex, and we'll take a look at another video later on. But you can do that by using the comparable structure, and we can take a look at that later on. However, when we're looking at this, we've got basically three ways of looking at it. We can either look for the biggest or the smallest, or we can just start off with the default value inside the list. I like to use for the biggest, starting off with integer.min value, or if I'm working with doubles, of course, double.min value. But with integer.min value, when I'm looking for the biggest, everything is bigger than negative 2 billion and change. So because of that case, Every time I compare against negative 2 billion change, whatever is bigger than that, oh, boom, that's now the biggest one. Oh, that's now the biggest one. And I always have an updated value of what the biggest thing inside that is. On the opposite side, when I'm looking for the smallest, I start with integer.max value. Because, of course, everything's smaller than that because it's positive 2 billion and change. Hey, anything smaller than that, boom. Okay, smaller, 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 smaller. And we're good to go. Finally, we have the more generic approach, and this is where we start with the 0th value of the item inside our list, and we compare against every individual value on that. However, with this one, I've found students often get confused because they think they're comparing against 0. And 0 is not really the best to search for the biggest or the smallest because values can have a wide range of numeric values. If we're looking for the biggest and we only have negative values, then 0 is bigger than all of those. And if we're looking for the smallest, we just give it 0, and they're all positive values that are greater than 0. We found the smallest not really because we just started at 0. So we don't want to use 0 as the default for that. Instead, I like using the inverse or the opposite of that. So biggest look for integer.min value, for smallest look for integer.max value, and use that comparison. And to see the code for this, you can see the code is exactly the same for the left and the right. The only difference that we have between these two different versions is I change what I'm looking for. So int smallest is equal to integer.max value, because again, that's the opposite. And then I say if zombie head inside the zombie list for each one that's inside there, if current.getGrossest level is less than smallest, because everything's gonna be less than max value anyway, then I'm gonna go ahead and replace my smallest with that current smallest value. So I'm always having the smallest current value attached to that. And finally, when I'm going through that, I have the smallest value you can return. On the opposite side again, find the est. I set est now this is the largest, so largest is set to integer.min value, and everything's gonna be bigger than that. So if current.getGrossest level is bigger than largest, I'll replace largest with that now new currently max value. And that way I can go through this. And this is just the find max or the find min algorithm going through and using a regular for each loop. Now, we also have to look inside the list to see if something is inside the list at all. And this requires, of course, a list reversal. And if we don't care about the position, we can keep using that regular for each we've been working with. But when we're looking at whether or not something is inside the list, we have to take a very close examination as to how we're looking for see if something is inside it. And this is where we have the difference between equals equals and dot equals. When we're comparing numeric values, of course, then we have the equals equals on int typed. Because equals equals on an int matches perfectly, we're good to go. However, with equals equals on a double, we have the fact that we don't know if those are exact matches, so we have to do the subtraction, look at the difference, see if it's okay enough, and that's another step we'll take a look another time. But equals equals on objects, we don't usually want to have the exact match object on that. And so instead, when we're comparing objects, we really want to use the dot equals. We see this especially with strings because it's a big deal how it operates, because sometimes it's a little squishy on strings. With the dot equals, we have to require us to override the method in the class that we're working with. And this can be as complex or as squishy as we want. And in order to do so, we have to add some stuff that's not inside the regular AP subset for computer science, but some really easy to do, and we can do some cool stuff with that with the instance of keyword and casting specific subtype objects. So let's go ahead and take a look at that. So here we have the isTheMatch object. It takes a zombie head parameter. And for each zombie head current inside my zombie list, I'm going to go through and say if the current zombie head is equal to the sample, there's an exact match because that's the object right there in the same space-time location. It's the exact same object. This expo marker is this X marker. They're the exact same. However, on the other side, I have else if current.equals sample. And is this purple X marker the same kind of purple X marker as this one? Yeah, I think they're the same. So these are equal. These are equivalent things, so I can say dot equals returns true on that. And it's a close enough match. And that's where we can really use some cool stuff with the dot equals. You can customize that as much as you want. We see that over here on the right with our dot equals method. First thing you can see on that is I'm using the @override notification, which is going to say, hey, this is overriding a method. And because it's overriding a method, we have a nice little notification. The compiler is going to give us a warning about overriding methods. We have to make sure that when we're using the equals method that we pass it an object type, not the actual type we're working with. Because you can call dot equals using the override method on anything. And so we have to actually make sure that's perfect. The first thing we're going to do is set Boolean match to false because, hey, we're good to go. If this equals other zombie head, if they are the exact same pointer, I'm pointing to the same exact lovely instance, then, hey, that returns true automatically. Then I'm going to say if this other zombie head is a zombie head. Oh, instance of. Are these the same kind of things? And so if that's the case, then zombie head other is going to be zombie head. I'm going to cast other zombie head as a zombie head. And then I'm going to check if the difference between this one's grossness level and this one's grossness level are the same. And if the grossness level is small enough, I'll return true. Otherwise, I'm going to go ahead and return the match. So that's what we're going for that. We have the example on that too. You can use the is there a match with either equals or that. You also can notify, you can also notice that the equals will also return true on a dot equals call. Because if equals returns true, then dot equals definitely should return true. Because if they are the exact same object, then they really should return true for the dot equals call. Now we have the classic piece of art from P.D. Eastman in the children's novel, Are You My Mother? But the big thing just said snort. Oh, you are not my mother, said the baby bird. You are a snort. I have to get out of here. And as the baby bird is trying to find its mother, we have the same idea. Can we find a certain thing inside a list? And so let's go ahead and take a look at that. When we find where are you inside the list, we have to actually look in where it is. And so we can do it a couple ways. We can use a regular for loop to go through and traverse the list and return the index when we find the correct one, or negative one if it's not found. We can't use a for each though, because we have no idea where we are when we're using enhanced for loops. So we have to make sure we use this. We also have inside the ArrayList class, there's the index of method. So if it returns true on the dot equals method, that'd be fine to go that, but sometimes it doesn't, so we want to actually write our own code to test that out. And so unlike all the other list processing methods we've been working with, we can't use an enhanced for loop. We have to use the regular for loop. We're using for you have to use regular for loop. For index equals z, index is less than list.size, index plus plus, going through each individual spot inside that list using the .get comparator. And so if it is an exact match, it can equals equals operator. Again, like I said, then we can use the index of method, but we're not really worried about that. So here we have the example right here using location, location, location. It's that really important thing. And so private int, where are you, zombie head search. We start off our index value at -1 because of course we want to assume that it's not inside a range that's possible for the list because it goes from 0 up to size -1. And then starting index off at 0, index is less than mylist.size, index plus plus. And if my zombie list.getIndex, so I'm going to take the zombie head out of my list, and if it equals that searched item, then I'll go ahead and return that index. Otherwise, that -1 value has been found, and I can just return that right there. So you have immediately a variable, we can return the correct value with it and go from there. And like I've always been doing, I like to have variables named rather than simply just use a magic return value on that. And so we have that right there. So I could just simply just say return -1, but I like to do it like this. And so that's where we're going with that. All right, so here we have the zombie head that we're looking at in those previous examples in the lecture. So we want to take a look at the code that goes along with it. And of course, our cute zombie head, I'm using the example since it was around Halloween when we did this class course. And so we got our cute little zombie head, and it has its grossest level because it's kind of gross and nasty, but it has a name. And we're using, of course, math.random, so we can assign a grossness level to each object by default, or give an assigned value on there. And we have our getters and setters that are just really standard and going for that. And again, like we saw earlier, we have our overridden dot equals method, so we can go ahead and say whether or not one zombie head equals this zombie head. It doesn't, sorry. But we have it built in so we can do that. And so we'll go ahead and take a look at that and see what happens. In order to do that, we're going into our controller class, and we have up right here inside my lovely demo the searches. We have right here, we can see int zombies favorites is a favorite count. We're going to display the message. There are this many zombie favorites, so we can see what's inside there. And we have our smallest zombie, my zombie head, the qualified grossness level using the certain grossness that we saw inside the lecture, as well as the sum of all the zombie grossness, the count of a certain name, the specified grossness sum. Check to see if a random existence is there, and then to see if my actual zombie, my zombie, is right there inside the list. And then finally, we're going to do some search strings in that, and we'll take a look at that. So we'll go ahead and play this code right here. And so we have 1 inside there. The smallest zombie has 13. The zombie head is located at 1. The qualified grossness, 3. The sum of all grossness in the zombies, 312 zombie grossnesses. Yes. Okay. We have a certain name, 5. So anything that's greater than Jack, we've got that. The specified grossness sum is 231. So we have a specified grossness. That totals 231. Random existence check. Oh, there was a close enough match. And there is another close enough match right there. Couple close enough exact. Looking for my exact one right here. Yes, there's an exact match. Hooray! And there was also a close enough match because if it's an exact match, there's definitely a close enough match. And some amazing computer scientists. We have here a quick little example of what we can use to go through the strings a little bit more, and so we can actually search a list of strings as well. And so to do this, we're going to take a look at an array list of string called CompSci women, and it's a new array list of string. And so we're going to add Analytical, Cassidoo, Amy J. Coe, Chloe Condon, Black Girls Code, Kelsey Henriksen, Sailor HG, or Sailor Mercury, Ria Galanos, Sarah Kazemi, and Alice Patel. And these are a few of the amazing computer scientists that I happen to know on Twitter. There are amazing, wonderful others out there as well, so I encourage you to go find them and look at them. But here are a few you can actually quickly look and find on Twitter. And so for index in CompSci women.size-1, index is greater or equal to 0, index minus minus, using the standard reverse traversal of the array list. So if CompSci contains an empty string, then we're going to display a message using our pop-up class, Fantastic Women in Computer Science on Twitter, and then using the getIndex value for that. So let's look at some amazing computer scientists. So I'll move that over here. And boom, Fantastic Women in Computer Science, Alice Patel, Sarah Kazemi, Ria Galanos, Sailor Mercury, Kelsey Hendrickson, Black Girls Code, Chloe Condon, Amy J. Coe, Cassidoo, and Analytical. So again, I encourage you to take a look and find some of these amazing women in computer science because they're great and they're cool people you want to know and follow because they also do some really cool stuff to help out computer science as a whole. And that's, again, how we can do some great processing using lists and strings inside Java, using the ArrayList type and using how to use a for loop to go through and look at that. So that's all we have to do is using a for loop, process it, do a search for that. In this case, we're using a simple search if the string itself has a blank string in it, which all strings do. So there you go. Thanks again and have a great day.